Good morning, students. I am Dr.R.Suganya, Department of Computer Science with Cybersecurity. Today we are going to say about why information theoretic secrecy changes wireless. So, which means that the theoretic secrecy, which means it is full of mathematical thing, okay, like some algorithms to be used, okay. So, theoretic secrecy actually refers to the study of cryptographic systems and protocols, okay, that provide unconditional security guarantees, often based on mathematical proofs only, okay. So often based on mathematical proof, that we call it as theoretic secrecy, which changes the wireless, okay. So here we have the core concepts of secrecy metrics like entropy. So we already know what is entropy. It is a fundamental concept in various fields. There is a measurement of entropy, that is quantifies the uncertainty or randomness in a system. And then we have the mutual information, conditional entropy, and equivocation. Okay, so these are the core concepts. And next we have the leakage based definitions. So according to the formulas that has been given, and cryptography and capacity perspectives, like the semantic secrecy, that is each and every meaning of the information, and capacity, how much it chooses the maximum bytes, okay. So here we say that maximum reliable rate R, where chosen secrecy condition holds bits per second per hertz, which depends on wiretap fading. And the design guidance uses semantic or strong secrecy for security and secrecy capacity. And then we have the equivocation rate, the formula, the residual uncertainty, okay. And we have some pros and cons too, and like for mutual information leakage and error exponent based. So how that is fading and mobility and interference shape secrecy metrics happens. Like signal noise ratio reduces reduces the particular secrecy capacity and increases secrecy outage probability. And here in second mobility, the time varying channels causes the signal ratio to be mismatched. And interference, if we say, interference can degrade legitimate link but may confuse eavesdropper, treat as a resource. Aggregate effect, which uses probabilistic metrics, okay. And channels, models, and secrecy capacity, that is like wiretap channel, fading wiretap, and memo secrecy. Signal sender, legitimate receiver, and passive eavesdropper. And here the model is random fading gains for Bob and Eve. And the memo secrecy, here multiple antennas will be there for transmitting and receiver. So we have the capacity range, like which underscores unequal. And here fading wiretap, we have the parenthesis, and we have some set of rules and regulations. And here for memo secrecy, we have like legitimate channels which dominates the eavesdropper, and we have some assumptions too for each and every channels, okay. So like how the data estimators and confidence work on it, like leakage in practice. That is, first when we collect the data and how the estimator collections and how the confidence assessment happens, and what will be the resource constraint and what will be the common pitfalls. So the data collection, which means they capture the legitimate and adversary observation with timestamps, signal ratio. An estimator selection, they choose plug-in entropy, KNN mutual informations or model-based likelihood. Confidence assessment, use bootstrap or concentration bounds. And resource constraints like account for mobile CPU, memory, and energy limits. And common pitfalls like ignoring temporal dependence. Okay, and we have the fading absent to present and signal to noise ratio based version versus information theoretic. Okay, and there are some limitations, misconceptions, and open research directions. Key limitations, that is model mismatch, ideal CSI options, high sample needs and trade-offs. Common misconceptions like secrecy, capacity, guaranteed perfect secrecy, and signal ratio margin alone, where asymptotic results will not be followed. and prioritizing open problems. Okay. And here the practical guidance, recommendations, tools, and what will be the first experiments. First is metric selection checklist. Use mutual information leakage for proofs and rate for intuitions. Next is plan the measurement, like collect synchronized observation, annotate the signal ratio. Okay. And suggest tools and methods. So what tools we can have? K nearest neighbor method for mutual informations. And experiment like measuring the labeling without artificial noise, and compute the secrecy outages. Okay, so there are some case study topics also, like secrecy capacity analysis in wireless channel with eavesdroppers, entropy and mutual information metrics for secure wireless transmission, equivocation rate based secrecy evaluation in mobile communication system, perfect secrecy achievement using information theoretic metrics, and information theoretic security versus computational security, a wireless case study. Okay, and thank you.